Hi, ma'am. This is T. Kushi from ITA, and my topic for Tech Talk for Dbms is a data structure for fast region searches. So let us know first what is searching. Searching is the process of finding a given value position in a list of values. It decides whether a search key is present in the data or not. It is the algorithmic process of finding a particular item in a collection of items. It can be done on internal data structure or on external data structure. So searching is nothing but in a given array of elements. To search an element, to search a particular element, you will have different techniques. So let us look into it. So we'll have internal data structure or external data structures also for searching. So coming to searching techniques, to search an element in a given array, it can be done in the following ways. One is sequential search, which is also known as linear search, and the other one is binary search. So coming to linear search algorithm, linear search is also called as sequential algorithm. It is the simplest searching algorithm. In linear search, we simply traverse the list completely and match each element of the list with the items whose location is to be found. If the match is found, then the location of the item is returned. Otherwise, the algorithm returns null. It is widely used to search an element from the unordered list, that is, the list in which items are not sorted. The worst case time complexity of linear search is big O of n. So coming to linear searching algorithm here, when the elements are not in a sorted manner, then you are going to use this algorithm. So each you traverse through the complete array and you will match the arrays sequentially in an order to find the element. The steps used in the implementation of linear search are listed as follows. First, we have to traverse the array elements using for loop. In each iteration of for loop, compare the search element with the current array element, and if the element matches, then return the index of the corresponding array element. If the element does not match, then move to the next element. If there is no match or the search element is not present in the given array, then return -1. So this is the procedure how we are going to write the program for linear search. And remember, linear search is also called as sequential search. So coming to the algorithm, linear search, that is, we are going to see the algorithm. Linear search of a comma n comma val. A is the given array, n is the size of the given array, val is the value that is to be searched. So step 1 is that you are going to set pos is equal to -1, set I is equal to 1. Repeat step 4 while I is greater than or equal to n. If a of I is equal to val, then set pos is equal to I and return pos. Go to step 6, endif. Set I is equal to I plus 1 and end the loop. Step 5 is that if pos is equal to -1, so you're going to decrement the value. Print value is not present in the array. Step 6, exit. So this is the algorithm of the program for linear search or sequential search. Let us see the program. So def, that is definition, def linear search value search, comma for. So first you're going to take a value and initiate it with 0. And you're going to take another value and initiate it with false. So match the value with each data element. While search of 80 is less than length of values and search of rest is false, then if values of search is equal to search for, then search is equal to true. Else search is equal to search plus 1. Return search. So here the array elements that are taken is 64, 34, 25, 12, 22, 11 and 19. So you're going to call the function which is written above, print linear search of 1, L, 12 or print linear search of L, 91. So you're giving two values for searching element, that is 12 and 91. So as you can see in this, so when you search for 12, you will get the output will be as element found at index 3. Whereas when you search for element 91, you will not get any output because there is no element present there. So coming to the linear search time complexities, best case complexity in linear search best case occurs when the element we are finding is at the first position of the array. The best case time complexity of linear search is big O of n. Coming to average case complexity, the average case time complexity of linear search is big O of n. Worst case complexity in linear search, the worst case occurs when the element we are looking is present at the end of the array. The worst case in linear search could be when the target element is not present in the given array and we have to traverse the entire array. The worst case time complexity of linear search is big O of n. The time complexity of linear search is big O of n because every element in the array is counted only once. So you'll have, while you're finding time complexity, you'll have three of them, that is best case, average case, and worst case. Generally, best case is denoted by symbol omega, and worst case is denoted by symbol big O, and average case is denoted by symbol theta. But generally, you use big O for all the notations. So best case complexity is big O of 1. Average case complexity is big O of n. Worst case complexity is big O of n. So these are the time complexities. So here you can see again the same thing which has been written. So what are the advantages of linear search? So linear search is easy to understand. Linear search is a simple algorithm that is, it is easy to understand and implement, making it a great option for beginners. It works by sequentially checking each element in a list until the desired element is found, making it a straightforward process. Next is no special data structure is required. Linear search can be applied to any data structure, making it a versatile option. It does not require any special type of data structure like a balanced tree or hash table, which can make it simpler to implement. And it can be used on unsorted data. So linear search can be used on unsorted data, which can be an advantage in certain situations. This is the contrast to other search algorithms like binary search, which require the data to be sorted. Next is no additional memory is required. In linear search, does not require any additional memory to be used, making it more efficient in terms of memory usage. This is a contrast to other search algorithms like hash table, which requires additional memory to store the indexes. Not affected by data size. So linear search is not affected by the size of the data and can be used to search for elements in large amount of lists. This is because the algorithm takes the same amount of time to search for an element regardless of the size of the list. So coming to the disadvantages of linear search, first, it is time consuming. So linear search can be time consuming, especially when dealing with large lists. It checks each element one by one, which can take a lot of time when searching for an element in a long list. This makes it less efficient than other searching algorithms like binary search. Next one is not suitable for large data sets. So linear search is not as sufficient as other searching algorithms when it is dealing with large data sets. It can take a long time to search for an element in a large list, which can be significant disadvantage when dealing with a big data. It is not suitable for unordered data. Linear search is not suitable for ordered data. Other search algorithms like binary search are more efficient when searching for an element in ordered data. Not suitable for repetitive tasks. Linear search can be time consuming and inefficient when used for repetitive tasks. It is not suitable for tasks that require multiple searches, as it will take longer to search for the same element multiple times. And it is not suitable for real-time applications. So linear search is not suitable for real-time applications as it can take a long time to search for an element. This can be a significant disadvantage in applications where a quick response time is required. So the next one is binary search algorithm. So binary search is the search technique that works efficiently on sorted lists. Hence, to search an element into some list using the binary search technique, we must ensure that the list is sorted. Binary search follows the divide and conquer approach in which the list is divided into two halves and the item is compared with the middle element of the list. If the match is found, then the location of the middle element is returned. Otherwise, we can search into either of the halves depending upon the result produced through the match. So this is the algorithm. So procedure, first you will take procedure binary search. A is sorted array, n is size of the array, and x is a value to be found. So set lower bound to 1 and upper bound to n. While x not found, if x is not found, and if upper bound is greater than lower bound. Exit, x does not exist. Set midpoint is equal to lower bound plus upper bound minus lower bound by 2. If A of midpoint is less than x, then set lower bound is equal to midpoint plus 1. If A of midpoint is greater than x, then set upper bound is equal to midpoint minus 1. If A of midpoint is equal to x, exit x found at location midpoint. End while end procedure. This is the procedure. You will take an array of elements, and in that array of elements, here the array should be sorted. You are going to take the middle element and check it with the element that is to be searched. If both elements match, then you will return that middle element. If it doesn't match, the element which is to be searched, you will check whether it is less than the middle element or greater than the middle element. If it is less than the middle element, you will only search in the left half. If it is greater than the middle element, you will search in the right half. So this is the procedure followed for binary search. So here you can see the algorithm. So def search list of n. L is equal to 0. U is equal to length of list minus 1. While L is less than or equal to U, mid is equal to L plus U by 2. If L of mid is equal to 1, then pause is equal to mid. Return true. Else, if list of mid is less than n, L is equal to mid. Else, U is equal to mid. So take the list. Here we are taking the elements 4, 7, 8, 12, 45 and 99. So the element which is to be found is 45. So if search list comma n, print found at position plus 1, else print not found. This is the program. So binary search complexities, best case complexity. In binary search, best case occurs when the element to search is found in first compression. When the first middle element itself is the element to be searched, the best time complexity of binary search is big O of 1. Average case complexity. The average case time complexity of binary search is big O of log n. And the worst case complexity. In binary search, the worst case occurs when we have to keep reducing the search space till it has only one element. The worst case time complexity of binary search is big O of log n. So these are the time complexities. Best case big O of 1, average case big O of log n, and worst case is also big O of log n. So what are the advantages of binary search? It is better than a linear search algorithm since its runtime complexity is big O of log n. At each iteration, the binary search algorithm eliminates half of the list and significantly reduces the search space. The binary search algorithm works even when the array is rotated by some positions and finds the target element. What are the disadvantages is that the recursive method uses stack space. Binary search is error prone. Some of the common errors are as follows. Off by 1 errors, that is while determining the boundary of the next interval, there might be an overlapping error, handling of duplicate items. While returning the first item, it might be possible we return a subsequent similar item. Next, numerical underflow or overflow. In huge arrays, when computing indices, there might be overflows. Recursive versus non-recursive implementation, which should be considered while designing as recursive tasks takes stack space, and it is catching is poor. And always in the binary search, the main disadvantage is the array of elements which are taken should be sorted. So thank you. I hope you have understood the topics. In this PPT, we have covered about what is searching, what are the types of searches, their time complexities, their advantages and disadvantages. And I hope you will understand that when you compare both linear search and binary search, linear search is a bit not efficient when compared to binary search. Binary search is more efficient because you can find an element in less number of ways. It reduces your time complexity as well as your space complexity also. So binary search is better than linear search or sequential search. Thank you so much.